We ready? Y'all doing good?
Ready.
All right. Let me make sure I can see myself here. Hopefully you're in the right place. Math 2412, section 36, it's Precal. Everyone's in the right place? What's up, man? Doing good? So I'm going to shut this door. I just don't like the door open. Something about it. How many of you were able to get into Canvas and take a look at this website yet? Good part of the class? Okay. So since this is a college level course, I'm going to assume that everyone here is comfortable, getting into the syllabus and reading through that on your own, and not going to eat up a bunch of class time going through reading things to you. But here's the syllabus. I will bring it up just to point out a few things that I think it's important for us to understand on day one. And that is my office hours. So I have really good office hours on Mondays and Wednesdays. Those are days you can come in and visit with me if you have questions over any of the work. I'm there from 10:45 to 2:45. That might change, by the way, but I'll change it in here if it does. On Tuesday, Thursday, unfortunately, I've got a pretty booked schedule here. So right after this class, in my office for about an hour. Now, if you need to make an appointment with me or something, you can do that, all right? So those are my walk-in office hours. The materials you need for the class are the Sullivan book here. Now, does anyone have like the paper version of this? You do? Okay, so I think it's cheaper. You can get it at the bookstore. And this is the same book you used if you took 1414 here, right? So that's good. You only have to pay for it one time. And what else? Again, you should read through this. This does not qualify as going through the syllabus. I just thought we would talk about the grades. In this class, you're supposed to keep a binder, or what we call a portfolio, and that binder is going to contain all of your work, and that has to be turned in at each exam. And so you can read through the syllabus to see what's required, what things have to be in that binder. It's really just to help you be organized, and the better organized you are, usually the better you do in a class. So that, and along with any homework, that's going to be 10% of your grade. Quizzes, which will come in the form of, you can let them in. Quizzes, which will come in the form of, hey, everyone take everything off your desk, we're going to do a quiz. Or it could be, hey, we're going to do a group assignment. It could be, let's take attendance today and give you a quiz grade because you're here. I mean, it could be any type of thing that I can come up with, really. Okay, so always be prepared to have a quiz. Then you'll have 3 exams throughout the term that are 60% of your grade, and then a final exam, which is the same weight as the other exams. It's just you get a longer period of time for that final. There's things about makeup policies, late work, all that type of thing. I do not collect homework, but at the binder, I do check. At the portfolio, I will check that at the exam, and if you don't have homework, then that's going to impact your grade. So I'll let, again, you read through that. I do have a policy on cell phones in the class. Unfortunately, I do require that for an hour or 40 minutes that you kind of disconnect yourself from the virtual world and keep your phones away. All right? Put them away, and we won't have any problems. Now, if you are using them, then I will penalize you 10 points on your next exam, and you'll be asked to leave. You'll be counted absent. So kind of not a good situation for you. I know that sucks, but you have an opportunity today. If you'd like, I can help you transfer into a different class where a professor is a little bit more flexible. But I walk around. Sometimes I look through classrooms as I'm walking around, and I see students sitting there on their phones and teachers just up there, and I'm like, that is never going to be my class unless they tell me I can't put the rule in there or something. So I expect your attention for an hour, 40 minutes. If you have something that you need to take care of on your phone, just step out of the class. It's really more about respect. Not like I'm demanding respect from you, but just like I think it's respectful to not be on your phone while you're in this class. But take it outside, we have no problems. Just don't be leaving 15 times to go update your Instagram, whatever it is, you know, just, I think you can do it. I think it's doable. All right, there's also a policy here on being disruptive or sleeping during class. Normally I don't have an issue with that, but the last semester I did have a unique situation where I had the sleeping problem in the class. So again, 10-point penalty on your next exam, you'll be asked to leave. So if you're that tired, you know, just take it to the hallway, go find one of those really nasty benches, sleep on one of them. Or just stay home, take an absence, get caught up, whatever. You know, I record all my lectures, so that's what the camera in the room is for. So everything I do up here is recorded, it's posted on YouTube, and you know, so this lecture will be on YouTube today, later on. So if you miss a class, that's fine. You're allowed to have 4 absences. Now, I don't recommend you miss 4 times, but you're allowed 4 before I can do anything. And after 4, I can drop you or fail you, regardless of your grades. So you get 4 free ones. If you're that tired or you're sick, we understand. That's why you get 4, right? So you watch the video, you get caught up, and all is good, all right? But not in the classroom. Don't sleep in here. So if you feel that little nodding going on, you know, if you start to feel that, go outside, do some push-ups, go up and down the stairs a few times, whatever you need to do, go wake up, come back. All right, that's all I'm going to go through. There's the schedule. This is the day by day, blow by blow, what's going to happen, except we've already been pushed back a day because we had the great winter storm of 2018, right?
No snow.
What's that?
No snow.
No snow, yes, but you know, we like to have good stories on the head, you know, in the news, you know, big old snowflakes in the background, 2018 winter storm, isn't it awesome? So we are behind, but that's all right. We'll get caught up somehow. And then we have what days the exams are scheduled, what they will cover. You get spring break, and I did put exam 2 before spring break, which is probably good. And then we come back, and then there's another exam somewhere down here, and then you have a drop date in here, and when the final is. Final is on a Tuesday. Okay? So that's the syllabus. Come on. Now, on the main homepage of our class, we have the link to the lecture videos. So the video, like I said, everything that I do in the classroom, you click on that, it'll take you to a YouTube playlist. You can go back and watch those, all right? And the video is really for 2 reasons. One is, like I said, if you miss class, I mean, you've missed class before and come back, right? And you're like, is this the same class? Like everything's like foreign, right? You know what I'm saying? So at least with the video, you'll get that gap filled. So that's the first reason. The second reason is because I really want you to pay more attention to what's happening and trying to like process the information rather than sitting there like writing everything I'm saying down and trying to decipher it later. So you always have the video to go back to, all right? So that's the reason I like to record the classes. So that will be the link to that. And then I also will have a link to the homework solutions. So I'm going to click on that now because I do have some in here right now. Last semester I taught Precal, but prior to that I hadn't taught it in probably 3 or 4 years. And I started doing the video solutions about 2 years ago. So my calculus sequence, Cal 1, 2, and 3, I have all the homeworks done for all the entire semesters for all those classes. But for Precal I don't. And last semester I fell behind. I just had a lot going on in my life and I fell behind. So I didn't get all the videos there for my students. This semester, my plan is to always be ahead of the class in terms of the videos. So right now, the homework for this section that we're going to cover today, the homework video solutions are there. So every problem that I assign, you can click on that video and it's me sitting there on a whiteboard working out the problem. Now, it's kind of like a solution manual. It's supposed. Let me tell you the way it should be used. There's two ways that students normally approach my videos. They'll watch the homework solutions and they'll be like, just watching it, and they'll be like, yeah, I can do that. Yeah, I can do that. And it's just like when you're sitting here in class and you're watching me and I do it, and the problem with that is I'm guiding you, right? I'm going down the road. I know which way to veer off, and I know which directions not to go, and I don't make the mistakes. Well, I'm not supposed to make mistakes, right? And so it's easy to watch me do that. It's different when it's just you and you're sitting there and you have to, create your own path. So the way I recommend you use these videos is you sit down with the homework, start working through the first problem, have my video there, and then as you work through a little bit of it, play a little bit of the video, see if we're on the same, path, and then continue and just kind of check yourself as you go. That's the way I intend them to be used. If you just use them as like I said initially, just, oh yeah, I see how he did, I got it, then I think you'll struggle in this class. I mean, I'm sure you've learned by now you have to do math to really get good at it. So, but I think it's better than the solution manual, in my opinion. All right, so there's all those. And then the class files. Come on. So I have the schedule, which I already showed you, but this is a printable version, so you can download that, print it out. I recommend you do that. And then formulas. So there's different things that we're going to need in this class. The unit circle, there's a blank unit circle, and then a unit circle that's already filled out. And then I actually took the formulas that we use from our calculus textbook, and those are the formulas that I'm going to allow you to use on certain tests. So I'll let you know when you can and can't use those formulas, but the reason why I'm using the formulas from the calculus book is because most of you need Cal 1, right? Okay, so I want you to get familiar with the formulas out of that book because that's really the one you're going to use mostly. So that's what we'll be using. And you'll see them later. I'll bring them up as needed. Okay. Now I have an assignment that is due tomorrow. Now it would be different if we had met on Tuesday because then this wouldn't seem like the next day, right? But I'm going to keep this as due tomorrow. All this is you click on this, it's going to be a quiz. It says it's a quiz. I'm going to count it as a quiz grade. But all it is a one-question quiz, and it says, have you read, oh, oops, I misspelled something. Have you read the syllabus and fully understand the requirements of this course? Yes or no? So this is you signing off on the syllabus. And that way, when you come to exam 1 and everyone's got these binders and these portfolios and they're putting them on my desk and you're sitting there going, what is that? And you're like, I had no idea. I'm going to bring this up and I'm going to go, oh, yes, you did. Right? So now if you put no, then that's fine. You put no, but it'll be wrong, and then I'll find you and I'll say, what's the problem? What don't you understand? Let's clarify what we need to clarify. Okay? So, yeah, you can say no, but then I'm going to come looking for you. I need everybody to pass that quiz at some point. All right, so you think you can handle that by tomorrow? Yes? All right. And there's some other stuff over here I'm not going to go through. Discussion board, you can communicate with your classmates, things like that. These two things, I keep them here. No one ever uses them. It's online free tutoring. Okay. No one's ever told me, man, that is outstanding tutoring online. So I don't know what that's really like, but it's there. And then we have this is like an online whiteboard meeting where you can like have a meeting with classmates and like draw on boards and you can, be at your houses and help each other. I don't know. So, okay, questions?
Is
yes.
the textbook the same from last year for algebra?
It should be, yeah.
Yeah.
Are you in here? Come in. Oh, she's locked out. You can let them in, or whoever it is, as long as they look like they're not here to do damage. All right. How you doing? There's a seat here if you don't want to have to, and you're free if y'all want to move that table however you want so you're more comfortable. Okay, so textbook, yes. This is the same one from college algebra. Okay. And while we're on that topic of strange people showing up at the door, I always like to talk about, in the event that we have some sort of situation where we are pinned down in this room and there's something very bad happening out in the hallway, whether or not we have an exit point. So this, we are on the 3rd floor, but there's an awning right here. This awning is, I mean, it's probably 2 feet, okay? So we could go out this window and then you could follow that awning and you could probably jump off the awning and survive. So, wait, are we on the 3rd floor? Yeah, we are on the 3rd floor. So anyways, that is an exit point in the event that we ever are in a situation. Okay? Okay, so anything else you want to discuss here? No? So what is Precal about? No, there's 2 other things I want to talk about. My cell phone. On the syllabus, I provide you my cell phone number. Now, I don't do this because I like my students to have my cell phone. It's because I teach 3 online courses, and as an online instructor, we're not required, but I think it makes sense to be available to students since I don't have to show up to a classroom. I make myself available to my internet students. They can text me, call me, whenever. And so I offer the same thing to all of you, that if you need to get in touch with me, you can. So this is not an official means of communication. Like if you need to tell me, hey, I'm not going to be there for class, or I'm not going to be there for a test, I'm on the side of the road with a flat tire, that needs to be emailed. Okay, that's official. But this is more like you're at home, you're working through something, you cannot figure out like why you keep getting this wrong. You can take a picture of the work, you can take a picture of the problem, take a picture of the work, and you can text it to me. And then I can actually write on my screen and edit your text and send stuff back to you and find your mistakes. And so I invite you to utilize that also. Don't ever feel like you're going to bother me. Like I said, I've got 3 online classes and they bother me all the time. So I'm used to it and it's part of my job. So, okay, it's there. And then the other thing I wanted to discuss is this common theme that I'm trying to have with all my classes this semester, and that is work ethic. Okay, so I've been teaching college level math for a long time. Since back when I was in grad school, I taught classes in grad school. I've been here for a long, long time. And this is probably the one element that has changed in my career, that has really, really changed. And you know, with math, I'm not a big believer in changing the curriculum, I don't believe in lowering the bar or doing anything like that. I think it's a disservice to a student to lower the bar and give them some false expectation or false impression of what real world is, I guess. And I'm not here to preach to you. I just want to make sure you understand that this is probably the single most important element of this class, is your work ethic. If you fail at this, trying, that is different than failing with no effort, all right? And I'm not saying you're going to fail, okay? I'm not like, most of you are going to fail. When I took Precal in college, okay, this is a true story. I went into that class, there were 270 students in an auditorium, okay? And our teacher was way down there at the bottom of the auditorium. And I sat down, and the first day she says to us, there are 270 of you here today. I expect to see 20 of you here at the final, and I expect 10 of those to pass. That was day 1. And so I just dropped the class after that, you know, because I was like, I mean, that's not a very encouraging, I'm just like thinking, play the percentages. I'm probably not going to be in that percentage. So, you know, I'm not here to demoralize you. I'm here because I want you to be prepared for Cal 1. That's what I want to do. I want to prepare you for Cal 1. So how many of you need Cal 1? That's everybody. Anybody not need Cal 1? No?
From what I was told, I didn't.
Okay, what's your major?
Biology.
If you don't mind me asking.
Biology, but looking at transferring to A&M into their teacher certificate.
Okay, that makes sense then. Okay, so, but you need Precal. Okay, all right. So look, back when I was like, I keep on talking back when, I guess I'm getting old. Precal used to be the requirement for med school. Like that's all you needed. pre-cal or stats. And what happened is everyone wanted to become a doctor. So now like it's getting up to like Cal 2 to become a doctor because they're trying to weed people out, right? So we get more people in the calculus sequence in different majors. Anybody biology major need Cal 1? Okay, how about engineering or computer science or STEM? Okay, so you all need at least Cal 1 or 2. So I'm trying to prepare you for that. And I don't want you to walk into a Cal 1 class and just get slaughtered. And I don't want you to, I want you to know that this is the single most important part of it, is your work ethic. So pre-calculus is not, it's not like this class you have to do calculus. It's really about mental maturity, mathematical maturity, and understanding that whatever you think your bar is, like whatever you think your ceiling is of the highest you can reach mathematically, you're going to need to push that way up. Okay, you're going to need to believe in yourself that you can actually do more than you think you can actually do right now. Like I never thought I'd be teaching pre-calculus the day I sat down in the classroom for pre-cal and she told everyone that no one's going to pass, right? So I had no idea that my potential was so much further than it was at that point in time. I need you to understand that your potential is further out than you can actually comprehend right now, but it requires this. You're not getting anywhere without this. So I expect you to work hard. When I assign homework problems, I expect you to work them. I expect you to have questions, right? And we'll just see. I don't really know any of you in terms of, I don't know anyone's work ethic in this classroom. I didn't teach, I haven't taught 14 in a while, so I'm not familiar with a lot of you. So some of you could have great work ethic and we'll find out, right? We will find out. How many of you, if you don't mind me asking, are fresh out of high school within the last 3 years? Okay, all right. So I think that's one of our biggest problems right now with this whole work ethic thing is the high school culture right now. It's very difficult for high schools to not pass you. You almost have to pass. I mean, we're talking about teachers' jobs depend on numbers of success in their class. And when you have that, you have very high graduation rates and you have very high passing rates, which sound good on paper. But most students coming to me from high school do not have this element. Because, well, how many of you got to retake tests in high school? That's it? Really? Show your hands. How many of you got to retake tests in high school? It's all right. I mean, it's not your fault. They let you take retake. Okay, so that's actually a pretty low percentage from what I've been seeing. Okay, that in itself is a problem because it creates this culture of, hey, I don't have to really be ready because I'm going to be able to retake this, or and it just doesn't work like that in college. In college, you're going to show up for those exams, and what you score on that exam, that's going to be your grade. There's not going to be any like, hey, can I pad that up? Is there anything I can do? Can I write you a book report? What I need you to do, if you want bonus, is show up for the exam prepared. And then you won't need bonus because you're prepared, all right? All right, so let's see how this work ethic goes. I don't want to preach. I just really want to make sure you understand. I'm going to be looking at this semester. All right, any final comments before you dive into this pre-cal? Last wishes? What have y'all heard about pre-cal? Like, have you heard it's hard? Have you heard it's harder than 14? What have you heard? Haven't heard anything?
I took it last semester.
Yeah?
I just had to drop it because of
Okay.
life issues and stuff. But,
Okay. How far along did you get?
I almost got, I got all the way to the end.
Really?
Like the last few weeks, I was with Ms. Burnett.
Okay.
And I mean, it's you can get it as long like you were saying. If y'all put in the work for it, you're gonna get it. There's a lot that goes on in the pre-cal. There's all kinds of stuff that stems from pre-cal.
Mm-hmm. Good. So we have some experience in here. Good. That's good. I'm glad that you spoke up. What you got?
People change their majors for this class.
People change their majors because of this class? Like they go into engineering because of this? No. The other way around? Yeah.
Get that from the med students.
Well, I mean, look, I'm somewhere in between, okay? There's certain and again, I don't want to sit here and talk about philosophies and stuff because I'm not good at that stuff. I can do the math all day long, but when it comes to philosophies of approaches things, it's too subjective. But I will say this. There are some instructors who believe that at this point you have to be like a sharpened knife and you have to be really good at math to be able to be successful in engineering or whatever it is. Like, you have to be an A student math-wise. And I'm somewhere else, okay? I'm not there because my personal experience is that when I was in pre-cal, I was a terrible student, absolutely horrible student. And I wasn't really, it took me like work ethic. It took me actually making the conscious decision to put in 100% effort. And when I was able to do that, it all became easier. Now, I had to put in the time and effort, but I guess what I'm trying to get at is I don't want to make this course like a gatekeeper course where you don't, if you can't get through pre-cal, haha, you know, like, you must be great right now, because I don't think I got great until I was in mathematics. I didn't get great at mathematics until I was actually tutoring mathematics. Like, I was in graduate school, and that's when it all started to like come together, if that makes sense. So there's like a delayed reaction in terms of math. Like, the stuff you learn in here, you're not really going to master it until a few classes from now. And it's because you have to use it, right? So I don't want to change your major in this class. I don't want to change your major, but what I want to see is potential. Because I can recognize potential. It's very easy to recognize potential in a student. The problem with math is that part of it is effort, and the other part of it is almost like a gift that you have from within. You either kind of have that way of thinking or you don't, but then there's also the work ethic. If you have enough work ethic, you can get through, but you got to have a little bit of that kind of natural instinct for it. So, does that make any sense at all? Okay. Anything else? You ready to dive in? All right. To me, pre-calculus is kind of like a buffet. All right. There's a lot of different topics. Some of them are connected, some of them aren't connected. And again, it's just to get an overall big picture of some things and mentally, mathematically get to a maturity point where you're ready to handle calculus. And calculus is not as bad as you may have heard. I mean, calculus is very doable. The ideas are pretty straightforward, but it's the mechanics of it is hard. The mechanical algebra is hard. Now, Cal 2, I won't sugarcoat it. Cal 2 is tough. So, all right, let's get started. I'm sure you're eager. What do we got? It's 11:28, so we have about an hour, 10 minutes. Let's see how far we can get. We are going to start. I follow a different schedule than most other pre-cal classes. So if you go and you have any other friends that are in pre-cal, and you're like, yeah, that first day, lecture that we talked about circles, and your friend's going to be like, what? We didn't talk about circles. That's because, again, I have a different philosophy. I like to start out, in this class, I like to start out right away with trig, with trigonometric functions. I want us to start looking at things that are probably going to be new to you, unless you saw it in high school or if you're retaking the class. I want trig stuff right away. And then towards the end, we do some of the other things that most of the other classes are doing right now. I don't like to do a review of algebra. We will, but we'll review it as we need it, and then at the end we'll try and do a little review, all right? So we're going to start with Chapter 2, Section 4, and we're going to talk about circles. So let me get my book out here. So if you're trying to describe what a circle is, you're trying to verbally describe a circle. How would you describe it to somebody?
360 degrees with no corners or edges.
What's a degree? So I'm going to act like I don't know what that is because I don't. If I'm putting myself where I'm supposed to be right now, I'm not quite sure what a radian is or a degree is because I haven't introduced it. So I'm going to act like you're speaking some foreign language right now. I don't understand that.
An infinite loop.
An infinite loop, okay? So there you go. That even looks like infinity, doesn't it?
Sure.
Okay. See if I'm open to. There's no right answer or wrong answer. I just want to see how, if you're trying to explain this to someone precisely, what would you say?
I describe how to make a circle. I would say pick a point
Okay.
and a line of a certain length.
Okay. So you start with some point, and then you have a fixed length.
A fixed length of a line.
Okay. So I've got some fixed length here. Now what?
Okay, so in one end of the line is
Mhm.
1 point,
Okay.
and then sweep it around.
Sweep it
whatever
around.
draws out at the very end, that's your circle.
Okay, so you're saying if I have a point here and then I have some fixed length, let's say it's right there, then if I draw any point right here then that would be part of my circle?
That would be part of your circle, and whatever, and if you draw that, take that length and
Okay.
draw it around, then you have a circle.
So it's all the points
All the points,
that are
yeah,
what?
that are at the end of that line sweeps as it goes around. I don't have the right vocabulary. for it.
I'm trying to force it out of you. It's all the points that are
Equaling to the center, equal,
the same distance from
center,
some point,
right,
right?
right.
Okay, so you start with a fixed point, and you have a length. A circle are all the points that are at the same distance from this point. Every point that you can come up with that is equal distance from this point. So I know that's what you're saying. You're saying sweep it around, but
Yes.
so you draw it and you have this, right? All the points that are equal distant from some given point. All the points that are equal distant from some given point is a circle. Okay, so we're familiar with circles. That's why I like to start with this section, because we've all seen circles. We're comfortable drawing them, kind of get an idea of what they look like. All right, well, let's go a little further. I'm not going to quiz you ever, like give me the precise definition of a circle, okay? But I want you to think about how you would verbalize that, how you would try and explain that to someone if you had to. If I asked you right now to graph this, if I asked you to graph this, then what would you graph?
A cup.
A cup?
Up like a cup.
Okay. So we can use our standard XY coordinate system like this, and it would look like a cup, like a coffee cup or a mug. Okay, so the little parabola, right? Okay, so this would look like a parabola. And what this is, these points on this parabola are all the points that satisfy this equation. So like if x and y are both 0, it satisfies this equation. If x is 1, y is 1. If x is 2, y is 4, right? So every point that satisfies that equation, all those points together make up that graph. Yes? Okay, and I mean, you've studied all sorts of stuff in college algebra. Like that one is the square root function, and that kind of looks like a parabola that's been cut in half and laid on its side, right? Those are all the points that satisfy that equation. And then we get to, are we okay with this? Okay, then we get to this right here. And let's make this circle have a radius of 1. In other words, that distance is 1. This parabola, there was an equation for it, right? This square root function, there was an equation for it. What is the equation of a circle? And what is the major difference between these two and that picture? Can anyone tell me what the main, like, there's not, I guess, there's a lot of differences, but there's something very fundamentally different between these two and that one.
It doesn't fall back to function.
It's not a function? Is that what you said? Yes. This is not a function, is it? Why is it not a function?
Vertical line.
It fails the vertical line test. Right? So if I draw vertical lines, I'm always going to intersect these at one point, at the most one point. Never going to cross it more than one time. This one I'm never going to cross more than one time. But when I get to the circle, I'm going to cross it, if I put this vertical line, I'm going to hit it twice. And that means this fails to be a function of x. Because you have an x input and you have two outputs. Here, if you have an x input, you have a single output. Okay, so it fails to be a function. But does it have an equation? Okay, what is the equation of that circle? Anyone know what it is?
Pi something, for 360, right?
Well, I want the whole circle, but I want the equation in terms of x and y.
Oh.
Like this is the equation of this. This is the equation of this. Do we have an equation that would do this? So I just wanted to see if anyone had seen it before. The equation of this circle is x squared plus y squared equals 1. That's the equation of that circle. Now this is a very special circle that I drew on the board. This is actually called the unit circle. And we are going to become intimately acquainted with the unit circle. They call it the unit circle because the unit comes from the idea that the radius of this is 1. And you can see that right here. Every point on this circle is 1 unit away from the center of the circle. Now, where is the center of this circle? What is the center? As a point, what is the center of that circle? 0, 0, right? Which is the origin. Yes? So not only, we call it the unit circle not only because it has unit length, like a unit radius, but also its center is 0, 0, which we call the origin. Okay? The origin. So the unit circle fails to be a function of x. So all the stuff that we did that had to deal with functions we can't really do here. Okay? Like domain and range. We can talk about domain and range when we have functions. This is not a function, but there still is an equation that draws that. So these points, all the points on this circle, if you picked them, would satisfy this equation. Questions? I'm going to change it up a little bit. That's our unit circle. I'm going to draw another circle up here. This time, I'm going to change my radius. I'm going to make my radius 4. Can you tell the radius is 4 from this drawing? Okay. Any guesses as to what the equation of this one would be? Okay, x squared plus y squared equals, now 4 maybe? Because it was 1 over there? Well, it's actually going to be 16. Okay? Because I'm going to give you the general equation in a second. I just wanted you to see the differences right now, and then I'll give you the general one, all right? So notice again on this equation, or this circle that I drew, where is its center? 0, 0 again, right? Now, keep in mind, the center of a circle is not part of the circle's graph, right? I mean, the center is just like a reference point, but it's not part of the drawing. Here, the center here, 0, 0. Here, the center is also 0, 0. If I change this radius to 7, this would change to 49. So let's come up with a general formula, okay? In general, a circle centered at 0, 0 has the equation x squared plus y squared equals r squared. A circle, oh, I forgot to put with, you're going to have to add this in here, sorry, with radius r. Sorry, a circle with radius r centered at the origin 0, 0 has the equation x squared plus y squared equals r squared. So you can see now why this was 16, right? So that's a major thing we need to remember. But what if it's not at the center? How does that change the equation? It's got to change it, right? Something has to be different. So this one right here, the big key is centered at 0, 0. All right. So now I'm going to draw you a different picture, and I'm going to give you the equation. Let's try and figure out what's going on. All right. So for this one, here's your picture. It's to give you some reference as to where we are. I'll give you a moment to try and draw this. Okay, I'm going to draw some very light little grid lines here so you can kind of tell what's going on here. Wow, that was supposed to go through. Oh, this is terrible. Those are like little grid lines so you can tell where things are lining up. All right, does that make sense? I totally missed that. Okay. Can you all see it? I knew my drawings would suck. So what I did before classes, I just came up with this little thing to show you instead. All right. So where was that thing? It was, where was it? Where?
Center was at 4, no, over 3, up 4.
Over 3, it was up 4?
Yeah.
Everyone agree? Okay, and what did it look like the radius was?
To the 0.
Does that look like what I had?
It was 2.
The radius was 2?
Yeah, the radius was 2.
So that looks good then, yes? Yay or nay? That match? Okay. So you can tell from this picture that the radius is 2? Okay? But the center has been moved, right? It's no longer centered at the origin. So this whole, we can imagine if we would have had a circle, radius 2, right here, we've taken it, we've moved it over and up, right? Over and up. And the new center is actually the point, what, 3, 4, do you agree? Moved it over 3 and up 4. So do you remember how we moved things left and right in college algebra? What did we do to functions?
Added a number of some sort.
Yeah, so like, let's see if this rings a bell. Let's say we had y equals x squared. That would be our little parabola, right? But if we did y equals x minus 3 squared, that would do what? It would shift it which way?
To the right.
To the right. Remember, it was opposite of what you thought? So if it was minus 3, it would move it to the right 3 instead of left 3. We're going to do the same exact thing in our general equation. Remember our general equation? I put it on the board here a second ago. It was x squared plus y squared equals r squared, right? But if we want to move it if we want to move it to the right or to the left, I'm going to have to put something next to the x. And if I want to move it up or down, I'm going to have to put something next to the y. All right, so let me show you what the equation of this one is, and then we'll come up with the general equation. The equation of this is x minus 3 squared plus y minus 4 squared equals, what do you think? The radius squared. So what was the radius? It looked like 2, so 2 squared is 4. That is the equation of that circle. And since I've got this other one on the board, just so we're clear, the equation of this circle would have been x squared plus y squared equals 4. So do you see the difference between these two? All you've had to do is compensate for the center by putting minus 3 minus 4. Is that pretty straightforward? Okay. So now I'm going to move it around. Okay, go ahead. You see if you can come up with that equation. Go ahead and write it down. Are you okay? Yeah? Want some paper? I want to see if you can come up with the equation of that circle on your own. When you have it, raise your hand, and just you raise your hand real quick and then put it down, and so I can get an idea of where we are.
Solve the equation?
No, I want what is the equation of that circle? That's what I want. I can come check if you want. I'll come look at it if you want me to.
That was minus 1, right? Am I looking at that right?
Well, did it go up
Oh,
or down?
wait, hold on.
Did it go
I
up
didn't
or
count
down?
that. I messed up.
Okay. Oh, rethink it. Rethink it. Yeah. Okay. Squares. You forgot the squares on the parentheses. What you got? So these are minuses?
Yeah.
Okay. All right. See. We'll see. Okay. When I'm saying okay to you, I'm not necessarily saying it's right. Okay, I just want to see what you've come up with. Where are you at? Okay. Where are you at? Where am I looking? Right there. Okay. Okay. All right, so let's discuss this. Let's discuss this. I wanted just to see with what I had presented whether or not you'd be able to come up with the equation, because I hadn't given you the general formula yet, right? I hadn't given that to you. So in the previous problem, our center was at what? 3, 1, 2, 3, and up 1, 2, 3, 4. There was our center, and the radius was 2. That was our circle from previously. The center was 3, 4. And the equation, I said it was x minus 3 squared plus y minus 4 squared equals, the radius was 2, so it was 4, right? That's what the equation was? And we all were okay with that? I wanted to see how you would deal with the circle being over there. So what is the center of this circle? -7, -1, right? To the left, 7, down 1. What's the radius of this circle? 4. Looks like 4? Okay, so notice that, remember, back in college algebra, if we wanted to move something to the right, we subtracted in here, right? That means if I wanted to move it to the left, we do what? We add it. So far, this equation should be x plus 7 squared plus, now, this was the part that I saw different variations, is how to deal with the y. And I didn't tell you how to deal with it. I just wanted to see what you would do. This was what? I told you this was the correct answer, and it was -4, right? -4, but the y coordinate of that center was +4. So it's actually the opposite of the number. Just like we used -3 here, or -3 here, and we use -4 here, you're going to use the opposites of both of them. So this should be x plus 7 squared plus y plus 1 squared equals the radius squared, 16. All right, so if you didn't get that, that's okay. Again, I was trying to see how much information could you extrapolate from just simple, like one example. So now let's give you the general, like the big one, okay? A circle, radius r, centered at the point. Now, when I give you the point that it's centered at, I can't say xy because my equation already has xy in it, so I can't use that twice. So I have to give the center a very special set of letters, and the standard that we use is HK. So let's say you have a circle, it has a radius of r, and it's centered at the point HK. Then it has as its equation x minus h squared plus y minus k squared equals r squared. This is the big daddy right here. This works with all circles, centered anywhere you want it to be with any radius. Any circle, centered anywhere with any given radius. So look at it this way. If we're centered at the origin, didn't I give you a general formula for the origin? Yes? It was x squared plus y squared equals r squared, wasn't it? Well, if your center is the origin, these are both zeros. And then that's 0 and 0, and so x minus 0 is just x, and y minus 0 is just y, and it becomes x squared plus y squared equals r squared. But this is more powerful because it works for any center. So can you see how plugging -7, -1 in right here? -7 gives you the plus. -1 gives you the plus. And that's why this equation is this. Are y'all good? Okay, I'm going to ask you a different question now. I'm going to erase. Do y'all know what a tangent is to a circle? Do you know what a tangent line is? Or when I say something is tangent to something? Kind of? Okay, a tangent line is a line that intersects a graph at only one point. So let me illustrate with this picture. On this circle, if I draw this line right there, is it intersecting the circle at one point? No, right? It hits it twice. What would I have to do to make it intersect it once? Probably move it up a little bit. So right to the tip of that, right? I mean, it's just it can only go through one point. Right? That would be a tangent line. I missed it again, but you get the idea? It actually turns out that when you draw a tangent line on a circle, the point at which it hits, if you extend the radius out to the tangent line, this has to be a 90-degree angle, but we don't know what degrees are. We're acting like we don't. But that, for all circles, your tangent line is perpendicular to the radius line. But what's more important for me right now is, do you kind of get the idea of what a tangent line is? It would just touch the circle at one point. Sorry, I have to plug in my laptop real quick. I have a class right before this class. It starts at 9:30, so I was hoping my laptop would make it the whole way, but it appears it's not going to. All right, so let me draw a couple of points. I'm going to ask for a volunteer to come up here, but you'll be on camera, so if you don't want to, then don't volunteer. I just want someone to come up and use my little ruler and draw me the two tangent lines that go through those two different points. So it's two different tangent lines. And if I don't have any volunteers, I'll do it myself, but I'm giving someone the opportunity. Please, not all at one time, please. No? Okay, so let me do it this way then. Okay, I'm going to put a line here. It could be any one of, it's got to be a line that goes through that point, right? So it's one of those? Okay, so it can only be, what, somewhere around in here? Yes? Okay. And this one, same sort of idea. Like, that would be wrong, right? It can only be one line. So, okay. See, you could have done better. Now, there's a reason why I'm asking you about tangent lines right now. Because I want you to find the equation of the circle centered at -5, 6. Who was that? So I read the other day about a man who died by holding in his sneeze. He like ripped his something in his throat and then had major like bleed out. Anyway, just let it go. Just let it go. That's probably pretty rare, right? Okay, so I wouldn't worry about it. Okay, find the equation of the circle centered at -5, 6, right? But what do you still need if you're going to give me the equation? You need a radius, right? So find the equation of the circle centered at -5, 6, which is tangent to the y-axis. Okay, time to meet your neighbors. Y'all go ahead and talk to each other. See what you can figure out. That's all I'm giving you. I expect that you're going to start talking about, like, what does he mean by tangent? Draw some pictures, you know, try and figure out what's going on.